Hello, welders. This is a little lesson on figuring out how to solve the rectangular tank problem. For this problem, you're going to use your blue book. There's a few pages in there, and I'll go over where that information is. And then also, it's a good idea if you've got some graph paper or at least some blank paper that you could draw some pictures on and then do some calculations. Let me first go over the illustration here. I've drawn out a what looks like a three-dimensional rectangular tank. Those dashed lines are basically showing the hidden lines. So it's going to be a hollow tank. The tank is going to have the metal that makes up the tank is going to have a thickness, and we're going to be comparing two types of tanks. One is going to be made out of steel, in this case a 10 gauge steel, and the other one will be a 1/4 inch aluminum. And so both the dimension and the type of material is important because we're going to be answering two questions, and one of them is going to be how much each tank will weigh. And so we're going to use both the dimension and the type of material to calculate the weight. And we'll also figure out how much each tank holds, or the capacity, and we're going to figure out in how many gallons each tank will hold. Okay, so before we begin, let's just look at the blue book to see what pages are going to be important for you to look at or reference when you're figuring out these types of problems. So in the blue book, this is the first page of the last section, or the samples section. The first page is called the reference, or the welder's references page. And you can see right here we've got weights of metals. And this page, this part actually is going to be of importance for us when we're calculating the weight of either aluminum or steel. Okay, and so this is the pounds per cubic inch, and again I'll refer back to this when we get to that part, but this is important right here. Another page in this section is going to be a few pages in. It's the sheet steel, the US standard gauges for sheet steel. And in our particular problem, we're going to work with a 10 gauge. And so these numbers here are the gauges, okay? And then these decimal numbers refer to the thickness of those plates in inches. And so we've got some decimal inches here. So a 10 gauge is 1,345 ten-thousandths of an inch, okay? Or you could say 0.1345. You might have a problem that has 12 gauge, and so here would be the 12 gauge, and then you would find the decimal amount. There are some other pages in this section that will be helpful, and the next one I would recommend is the section in which we have the volume formulas. And if we go, let me zoom this in, right here we've got the square prism. Okay, square prism's kind of like a tank. The end is not necessarily a square, but the volume formula is what we're going to be paying attention to. V equals A times B times C. So each side is a letter, and so the length, the width, the height, A, B, C. Or if you think of volume of a rectangular solid, or not a solid, but this object, you know, you might think of it as length times width times height. That's fine. It's basically the same formula. We're just using different letters. So we are going to be using that. And then towards the end of this blue book section, on this page here, called the English system, on the very bottom, and I'll slide this up, we've got our conversions. So we are going to be working with cubic inches, and right here you can see that 1 gallon equals 231 cubic inch. And so we're going to be using this this equation, or not equation, but equivalence here, to convert cubic inches to gallons, and that will help us answer our capacity problem, or how many gallons will the tank hold. Okay? All right, let's go back to the setup. And again, if you want to if you would like to do this problem while I'm doing it, go ahead and pause the video. These are the dimensions that I'm giving you. It's a good idea to draw it out. And on your homework, I am expecting you to draw out the tank. Okay? Now, it really doesn't matter which one we start on. I'm going to go ahead and start on this tank A. And again, I'm reminding myself of what I'm trying to solve for. How much does each tank weigh, or how much does tank A weigh, and then how much does tank A hold? Okay? Now notice this illustration. I'm giving you the outside dimensions. So the length is 5 feet 4 inches, the width 4 feet and 8 inches. Kind of looks like 1/8, but that's 4 feet 8 inches. And then the height is 3 feet 9 inches. Okay, now if I were to just take these 3 dimensions and then multiply them together, that would give me the volume as if it were a solid. But notice this tank is not a solid. Okay, and so what we're going to be doing is figuring out the volume of just the material. Okay, so I'm just kind of drawing the material, the part that represents the material. And we'll do it over here too, on top. We don't want the volume of the whole shape because it's not completely filled in. Okay, we only want the volume of the material. Now, what we can do is, if we have the outside dimensions, that's as if we have the whole solid. So I'm just going to draw a little picture here on the side, and it's not going to be 3-dimensional. It's just going to be a 2-dimensional representation of what's going on. But I think you'll get the idea here. So if I have, okay, here's my solid. So in this case, it wouldn't be 3 dimensions, it's 2 dimensions. So really, if I make up some numbers, say this is 4 and this is 2, then it would be 8 square units, okay? But what I want to do is not take that whole amount. I just want to look at the area of just the material amount. Okay, so if I draw another piece, really what I want to do is just draw, or just calculate this amount here. Okay, so you can see that there's a part that's missing. The middle part is missing. Now if I were to know what those dimensions of that middle part was, okay, from here to here, and from here to here, I could pull that out, that amount out, and then what was left would be the area, in this case, of that rectangle. It would kind of be like a frame, right? So we want to take out a chunk of that area to get the remaining area of the frame. That's also similar here. We want to take out the inside, the air basically of this tank, so that we're only really calculating with the numbers that represent this shell, okay? So what we're going to do in both problems is we're going to figure out what these inside dimensions are going to be. Okay, so we're going to have a dimension here for the aluminum tank, and we'll have a dimension here for the steel tank will also have the height will be different, and also the width will be different. Okay? Okay, so let's go ahead and figure that out. Now, before we actually jump into that, I'm going to go ahead and change these feet and inches to just plain old inches. That will be a lot easier to work with. Get my green pen here. And if you want to double check with your calculator, go for it. So 5 times 12 plus 4 is 64. Okay. 4 times 12 plus 8 is 56. And 3 times 12 plus 9 is 45. It's going to be a lot easier to work in just inches. All right. Now, I'm going to do a little, I'm going to write it out here on this side here. Now, I know that my length on the outside is 64, but if I'm working with the 1/4 inch aluminum tank, which is right over here, I want to find out what this dimension is going to be. And if you draw a really good picture, you're going to be able to see what you need to take away. Notice we've got the thickness of the plate over here and over here. So really what we're doing is we're taking 64 minus a 1/4 inch, and then we're also taking away another 1/4 inch, and then the remaining amount will represent our inside dimension. Now obviously I've written it out here kind of long ways. You can easily combine this. If if you're working with easy numbers, do that. So really we're just taking away a 1/2 inch. So that's going to give us 63.5 inch. Okay? Now we're going to do that for the other two sides. Okay? These are going to be our inside dimensions. Okay? So let's try 56. 56 inches minus, actually I'm just going to combine 0.5. That's going to give me 55.5 inches. That's from here to here. And then again our height is 45 minus a 1/2 inch equals 44.5 inches. Okay, or 44.5. These again are our inside dimensions. All right, now let's go back and look at the picture. How are we going to use that information? Well, remember over here, if we said that if we take away that space from the original, we'll get this frame. And that's what we want. We want to take away this empty space from this three-dimensional object so that we really are only getting the cubic inches of the frame of the tank. Okay? All right, so let's use our volume formula, which is going to be V equals A times B times C. I'm going to first write it out. We're going to take our outside volume and subtract from that the inside volume. What we're going to get is the volume of the tank material. Okay? So we're going to find the outside volume. From that, we're going to subtract the inside volume. What's left is just going to be the volume of the tank material, or the shell of the tank. So that means we have to do a couple of volume formulas. we're going to first do 64 times 56 times 45. From that, we're going to subtract the volume of 63.5 times 55.5 times 44.5, and the result will give us the volume of the tank material. I'm going to go ahead and figure out what these numbers are. Now, I'll go ahead and do it separately, but if you're able to write this out, if you understand what we're doing here and write this out, you could plug it all into the calculator as one equation using the parentheses, and you'll get your answer. But I'm going to just go ahead and write it out, and then as you get better at doing these, you can try it the other way. So first we're going to go 64 times 56 times 45. It's going to give you a pretty big number, 161,280, and that's going to be cubic inches. We always want to include the unit of measurement. Now let's go ahead and figure out this inside volume. So 63.5 times 55.5 times 44.5. And again, it looks kind of big. We've got a little smaller though than the outside. So we've got 156,829. It looks like an eighth. I'm going to write it as a decimal though. Inches cubed. Okay, now I'm going to subtract these two numbers. And I get 4,450.875 inches cubed. Okay, so there we go. Okay, now that is our tank material in cubic inches. Now, if you remember, in the blue book, we have the page, I believe it was the first page that I showed you, right here. We're working with aluminum, okay? So aluminum is 0.0975 pounds per cubic inch, okay? So the way I'm going to set that up is we're going to start with this. I'm going to rewrite it as a ratio. So 4,450.875 inches cubed over 1. What we're doing here is a unit conversion. Okay, and this is going to work for any kind of unit conversion. Now, what we want is our answer to be in pounds. So we're going to put the pounds part on top in this second ratio, and the inches cubed down below, because then we can cross cancel and then just work across. So it's 0.0975 pounds per 1 cubic inch. That's what that means here. Right here. 0.0975 pounds per cubic inch. Okay. Now you can see that this is clearly going to be a multiplication problem, and our answer is going to be in pounds. So I'm going to take my calculator and multiply 4,450.875 times 0.0975, and I'm going to get 433.96, and I'll go ahead and just round to 2 decimal places, so that's going to be in pounds. So this tank weighs 400 33 and 96 hundredths of a pound. Let's go ahead and see the weight for tank B. Notice we're going to do the same sort of thing. We're going to be finding the outside volume and subtracting from that the inside volume, and then that's going to give us the volume of the tank material. And then once we find that number, we'll go back to the blue book, okay, and instead of looking up aluminum, we're going to use the number for the steel. So if you want to go ahead and see if you could solve this one, you could pause the video. If not, I'm going to walk you through it right now. So a 10 gauge steel is a little different than a 1/4 inch. So we want to go back to that page that has our gauges. 10 gauge is 0.1345. So I'm going to write that down, 0.1345 inches. Okay, and I want to convert 10 gauge to inches because all my dimensions are going to be in inches, and it's going to be a lot easier to work that way. Now, interestingly, the volume of this tank is the outside volume of tank B is the same as the outside volume for tank A. So we don't need to figure out that first number because it's going to be the same over here. What's going to be different though is the inside volume. So let's go ahead and figure out those inside dimensions on this side. Okay, so let me get my purple pen. And again, we're going to start with 64 minus, and notice again I've got a plate thickness here and a plate thickness here. Now I don't happen to know what that is off the top of my head, so I'm just going to write it out and then I'll let the calculator do the work. Okay, so again, let's go ahead and get a calculator. 64 minus parentheses 2 times 0.1345, close parentheses, and I'm going to get 63.731. And that's going to be in inches. Okay, that's the inside length. Okay, now we're going to do the same thing for the width and the height. So the width again is 56, but we're going to take away 2 plate thicknesses worth. 2 times 0.1345, and again we'll go 56 minus open parentheses 2 times 0.1345, close parentheses, 55.731. Okay, and then the last one is going to be 45. Oops, 45 minus 2 times 0.1345 equals, and I'm sure it looks like it might be another 731. We're not using any there's no weird fractions here. Okay, so 45 minus 2 times 0.1345. Yep, 44.731 inches. Okay, so those are our inside dimensions, just like we did before, just using a different plate thickness. Now, again, I like to write out my equation, especially when I'm learning new things or demonstrating. I like to use words. Helps some people. So outside volume minus inside volume equals volume of tank material, or you can think of it as the tank shell. We already know what the outside is. It's going to be, this number here. So I'm just going to write down that number, and then we'll figure out what that inside number is going to be. So we've got 161 280 inches cubed minus, and then I'm just multiplying all these numbers, so 63.731 times 55.731 times 44.731. Okay, all right, get out the calculator and punch in those numbers. Okay, and I'm going to get 158,875.2241 inches cubed. So let me bring this down, and then we'll plug it into the calculator. Now, I'm going to show you a little trick if you don't know this already. I'm going to leave this number in here, and then I'm just going to plug in this outside volume, and then we'll bring back this number, and I'll show you how. So we don't clear it. We just go 161 280 minus second answer. That brings up that old number, equals, and the difference is going to be 2,404.7759 inches cubed. Okay, now this is volume, so the volume of the tank material for the 10 gauge, that's what this number is. Notice it's about 2,000 less than the aluminum one. Okay, all right, now let's go ahead and convert this to pounds. So again, we're going to write that, we're going to do a unit conversion, so 2,404.7759 inches cubed over 1. And we're going to look over here in the blue book. Get to the right page. Now this one we're working in steel, so that's 0.2835 pounds per cubic inch. So let me write that. 0.2835 pounds per 1 cubic inch. And notice this is just a multiplication problem. We're going to cancel out those inches cubed, and our answer is going to be in pounds. So I'm just going to leave this number and hit times 0.2835, and we have 681.75. I'm just going to round to 2 places, pounds. Now it's kind of weird because this, we said earlier that the inside volume, well, here, let's think about this. The inside volume, or excuse me, the volume of the shell was about 2,000 cubic inches less, but notice it's going to weigh more. And that's because if you look at the conversion for aluminum, that's very small, 0.09 versus 0.2835. That's why we're going to have a much heavier tank with a steel tank versus an aluminum tank. Even though the cubic inches were, there was more, it's lighter, and that's because of this conversion number. So what we've done so far is answered one question. We still have to answer the other question, but thankfully that question is not hard. So let me grab another piece of paper real quick, and we'll do some more math. Okay, I'm going to move this aside. Now, come back here. What we want to do for number 2, how much does each tank weigh? Notice when if you have a box, a cardboard box, and determining how much the box is holding is the space that's in the box, okay? It doesn't consider the box's material, right? You're only really looking at what is what you're able to fit in the inside space. So capacity really focuses on this inside part. Okay? So it's going to be the inside volume. And all we're going to do is convert the inside volume to gallons. So that's a real easy conversion. And you already have the inside volume numbers. Okay, so for instance, for tank A, this is your inside volume. Okay, for tank B, excuse me, this is your inside volume. So we're just going to set it up so that we can now figure out how many gallons those volumes will hold. Okay, so let's look at, I'm just going to, I know you can't see the paper, but I'm going to rewrite it here. So tank A, okay, this is the aluminum one. Okay, so the inside volume is 156,829.125 inches cubed. Okay, that's the inside volume. Okay, now we want to create a ratio. We're going to do another unit conversion. So, let me get a different pen. We're going to put this number over 1, and this part's going to be in inches cubed, this part's going to be in gallons. Okay, now let's go back to that blue book. Oops. And I believe it was in towards the end, the English system page. Here we go. And if we look down here, 1 gallon equals 231 inches cubed. Okay, so the 1 is going to be on top, the 231 is going to be on the bottom of that ratio. 1 gallon is equivalent to 231 cubic inches. Now in this problem, notice that it's not a multiplication problem, it's really a division problem, because if we go ahead and multiply across, we're going to get 156,829.125 over 231. So really that's division, we're dividing there. Let me get my calculator. So we're going to just plug that in, 156,829.125 divided by 231, and we're going to get 678, and again I'll go 2 places, 91 gallons for tank A. Okay, now for tank B we're going to do the same thing. We're going to write down the inside volume, put it over 1, and then times 1 over 231, which is basically you're dividing by 231, so I'll put it down here. So tank B which is the steel tank, and that inside volume was 158,875.2241 inches cubed. Again, that's the inside volume. We're going to put that over 1, and again, cubic inches to gallons. You don't have to worry about if it's steel or aluminum, it's going to be the same thing. So we've got 1 gallon on top and 231 cubic inches on the bottom. Those cubic inches are going to cancel, and you're going to wind up dividing this number by this number. So 158,875.2241 divided by 231, and you're going to get 687.77 gallons. That's interesting. Looks like these numbers are reversed. I think that was just a coincidence, but kind of funny. Anyway, you can see that the steel tank is going to hold a little bit more. And, honestly, that, let's see, does that make sense? Yeah, it does make sense, because if you look at 0.1345, that is a lot less than a 1/4 inch, which is 0.25. So this shell is going to be a lot thinner than the aluminum, and so that means it's going to hold more. And even though it doesn't hold a ton more, it does hold a bit more. Okay? Anyway, I hope this helped. In class, please ask questions. We'll do a lot more problems, and there is another example in the blue book if you're interested. Thank you.